introduce this session, I'd like to invite you to check in using the details which are on the screen. So checking in not only gives you access to resources and information relating to similar topics that we run out of the reactor, but as many of you will know, for this series that we're running, we have a giveaway whereby participants who attend a minimum of 4 events will be in with a chance of receiving a free certification voucher. So these are usually valued at around $165 but if you attend at least 4 of these sessions within the series, you will receive one of these for free. So what you need to do is check in using the details which are on the screen in front of you to be in with that chance. So today's session is unlocking serverless. Today's session will run over the next 60 minutes. It is being recorded as well, so on-demand viewing is possible. I'll let you know during the session in the chat where you can access on-demand recordings of this series. So last week we kicked off on automating ML with Azure. And today marks the 2nd episode within this series. So if you do have any questions throughout today, feel free to drop them into the chat. I'll be moderating that chat throughout. There's also features in there like raising your hand if you have questions as well, and you can use that throughout the session or at the end when we have some time for Q&A. So just to quickly run through our code of conduct, this is something that we display at all Microsoft Reactor events, and it's really a reminder to everyone to be aware of one another. It is an inclusive environment that we have, so just to remain friendly and welcoming throughout, and if we do see any differences of opinions throughout, just to really be mindful of those. So today's speaker, I'm delighted to be welcoming Chris Noring. Chris is a senior cloud developer advocate at Microsoft and is also a fellow Swede, which you'll be glad to hear. So really excited to have Chris here. Chris, without further ado, I'll hand over to you to introduce yourself further and kick off the session.
All right, thank you so much, Emma. Yes, I'm a fellow Swede, so hey Sverige. Feel free to ask any questions in the Q&A in Swedish or English. I'll be able to answer both. Let's kick this off by starting the presentation. Let's see if I can share my screen. There we go. Emma, can you please confirm when you see my screen? That's all good? Perfect. All right, so let's talk about serverless. Serverless is a very exciting topic on Azure because there are so many different offers. It's not only just one, but throughout this talk, I'll talk through what actually is serverless because there's a lot of confusion to what this term actually means. So I just wanted to say that serverless is more than a function for those of you who understand what serverless is and maybe you tried one of the offers out. You could always reach me on Twitter after this talk on Chris_Noring. As Emma was saying, I'm a cloud advocate at Microsoft, which means I do presentations like these, I build tools, I help with documentation. So if you got any questions or queries on our docs, learn modules, any asks for content, definitely reach out at this point. So what is our presentation like? Well, first off, I want to explain to you from whence we came, because serverless didn't just happen yesterday. It's been an evolving course of a few years. And then I'm going to talk about what is serverless, what does this concept mean, because it's a bit interesting naming. And then I'll talk about how we can handle events at scale. We have definitely an offering for that. And then I'll talk about different ways of authoring workflows with serverless, because you can take it way further than just a function. And lastly, I'll talk about something called low code or no code, because there's a big revolution going on right now when it comes to serverless and using cloud in general, because you can leverage a lot of the cloud without actually authoring a single line of code, because a lot of the code is written for you. And the whole point of this low code, no code movement is for people who knows the business, that they can work together with different parts of the business to leverage a whole. Now, let's first start with the whole, how did we get to serverless? Because there's a reason why we are where we're at. We started on-prem. What does that mean? Well, we have our own physical servers at this point. This is a few years ago. For some of you, you're still here. You have some physical servers. Some of you might have partially migrated to cloud, in which case you have a hybrid environment, and some of you might have left those physical servers behind completely. But important to know about the whole on-premise is that we had a different type of questioning when it came to on-prem. We had questions that we needed to ask ourselves, like what size of server do I need to buy? How much budget do I need to allocate? Or how long does it take to provision a new server? And you needed to decide what operating system do I need to use? So you can see all of these questions are on very low level. And yeah, I mean, at the end of the day, what you probably want as a company is to focus on delivering features for your customers, not having to worry about this. And if you're here, you most likely have a whole department hired to make these kind of calls. Now we moved from on-prem to infrastructure as a service, and that means that suddenly I could log into the Azure portal and I could start provisioning servers. But at this point, I still need to be very detailed. I still need to say, I need a certain type of hard drive with this and that many gigabytes. I need memory, and I need to worry about how do I actually patch my servers? How do I do backups? Which OS, again, should I be choosing? Who monitors my app and so on? So I'm still at a fairly low level. I'm not at a level where I need to tinker with physical hardware, but my hardware is in the cloud instead, and a lot of decisions are still up to me. Now, some of you folks are gonna enjoy having that level of control, but if you want to move past that at a point where, hey, I don't actually want to care about this anymore, I move on to something called PaaS, and this is called Platform as a Service. So Platform as a Service is almost there in our evolution. So Platform as a Service means that the cloud handles everything for you. It handles to provision a server, it handles installing an operating system, and it even handles how to host your application. And it definitely handles scaling. That's not a problem that you need to worry about anymore. So hopefully, if a lot of you are here, that means that all you do all day long is to develop your application, and then you tell Azure, hey, here's my application, run it to the best of your ability. So that's what Platform as a Service means. Now, on top of that, we have built the whole serverless thing. And serverless in this case means that we build a service on top of Platform as a Service. That means that all the things with automatic scaling, all the things with hosting my app, this is something that serverless handles for you. So serverless is something that we dreamt up when we thought of what if an app actually is cloud native? What if an app is meant to run in the cloud? At that point, it makes it a very different kind of app, which I will soon show you. But the big question we need to ask ourselves at this point is, does the shift in architecture mean something? Does that mean that I can architect differently? I mean, so far I've been architecting apps in a certain way. I built my APIs, I deployed my code. But what if my app is no longer a 24/7 hotel that needs to be up and running? What if my architecture is different? Before we come that far, let's talk about what serverless is, because a lot of folks, I'm sure some of you who are listening right now is thinking, serverless. What do you mean less servers? Okay, sure, it's not my server, but it's a server in the cloud. So am I actually using less servers? So as I said, the whole naming bit with serverless is a bit, but the important thing to realize about serverless is that it's an abstraction, right? You no longer physically deal with servers. Those are not your concern anymore. And another key point here, the one in the middle, says serverless is about events and it being event driven. And what does that mean? It means that there are important events that happens in the cloud or outside the cloud that matters for your business. And that's what serverless is here to leverage. It's about to say, I'm going to be reactive. I'm going to react and I'm going to run code when something important happens. And also, as I said, because this lies on top of Platform as a Service, you still have instant scaling. You don't need to worry about how many instances of serverless do I need to spin up. And lastly, maybe most importantly, depending on who you ask, it uses something called microbilling. So serverless, right out of the box, is very, very cheap, and I will explain how cheap. It's almost cheaper than GlocalNet, so that's an internal Swedish joke, by the way, if you remember those commercials back in the 90s. So looking at serverless, you can see if I make 1 million calls and each function instance is using 128 megabytes and the function executes for a full second, it is completely free. So imagine what that means if you got a pet project, or maybe you have a startup, or maybe you have an enterprise business where you say, is serverless right for me? I mean, this gives you a lot of leeway to experiment. 1 million calls. But I bet some of you are thinking, okay, it's free now, but how expensive is it later? Well, let's have a look at later. Later, in this case, means 5 times as many calls. So we go from 1 million calls to 5 million calls, and we're still using the same amount of megabytes. We take a full second, which is super generous, by the way. Most functions execute in a matter of milliseconds. And see how much we're paying at this point, $4.40. It's still super cheap, right? But as I said before, everything comes down to your business. If your business needs to be up 24/7 with the type of functionality you have, serverless is probably not for you. So I'm going to take a moment to try to explain when serverless makes sense. Because I said it's event-driven. That means that something important happened for your business. And what kind of important thing is that? Well, imagine that you have a new customer, for example. That's not likely to happen every day, every second. If it does, congratulations. That means you have a fantastic business. But more likely than not, a new customer maybe arrives every 3rd day or every week or every 2 weeks. And imagine the onboarding process for that new customer. It needs to be an entry in a database. Maybe it needs to be a function that runs. Maybe it needs to be an email that's being sent out, or several emails. That's functionality that runs seldom. So in that context, serverless makes a lot of sense. Now, let's talk about a little bit more that what we can build with serverless, because we have a lot of options. So let's look at this first scenario. We have some kind of time lapse, something that happens every maybe 2 minutes, maybe every 15 minutes, maybe every 60 minutes. At that point, I want to run some code. So at every step of this time interval, I want to run code. And in this case, I want to find and clean invalid data that I have in a database, because we've all seen those scenarios. We might do like a raw request, and then we have data that's being dumped in a database, and we swear that we will take care of this later. So what we can do in serverless is that we can set up a job that runs with a certain time interval, and it can end up cleaning that table for us. So that's one use case. Another use case is, for example, when a file is added to a blob storage. And as you know, in a blob storage, we can store things such as JSON files, images, videos, some kind of file. And we want to know when that happens. And the good news is that we can listen to that event. So either if a file is being added, deleted, or updated, we can listen to that event. And as a result of that event, we might want to open up that file, because let's say it was a CSV file. We want to grab that data and insert that data into a database. So hopefully at this point, you can see some kind of integration scenario in front of you where we have this legacy system where the data is stored in CSV. And thanks to serverless, we can easily integrate with that system as soon as either there's a job that puts this file on the blob storage, or there's a physical person that just does a drag and drop. And we end up with rows being inserted into a database, or they are inserted into a data storage that Power BI, for example, could be reading from. And the end result is a nice little graph that shows you, oh, here are the sales from last week, and we can see the results from this legacy system. So this is definitely a good use case. Another scenario could be, for example, where if you're using a mobile app. And I think if you've seen Ignite, the tour, or the big Ignite, you might have seen this scenario before, but it plays out in the following way. So imagine that you have a mobile app, you take a photo, and once you take a photo, a webhook is being called. So when that webhook is being called, it stores that photo in a blob storage. And what you might want to do at this point is to do something with this image file. You want to make sure that you have something nice that you can display towards your end user. And that nice thing is a thumbnail, a mini version, because for several reasons, if you have a mobile app and you know that the user is on a low bandwidth, you don't want to show the full image that they just uploaded, but rather a smaller version, right? So what I'm saying with this scenario is that the image is being stored in the blob storage. We run an Azure function to create these thumbnails, and we end up pushing up the thumbnail to the blob storage. At that point, our mobile app can suddenly show these new thumbnails, and the user is happy, and they get this confirmation that they need, that this scenario played out well. Now, you've probably seen this scenario happen to you a few times. Imagine that you've been Googling for this new hardware thing you definitely want, right? Could be something that you go to some kind of e-shop or e-commerce store, or you Google for the next, I don't know, domain name that you want to buy. Regardless of which, what you are doing at this point is that you want to go into a web page, but you who build this web page, you ensure that a webhook is being called and that webhook reads through the user profile. At this point, when you read through the user profile, you can start saying, aha, this user is very interested in electrical guitars, for example. And based on that, you end up showing ads that matches this user profile, and you end up with a completed page where it shows the main content that you look for, but it also shows ads for electrical guitars. So this is definitely a scenario where serverless would make sense, because all of this is reactive. All of this is based on a user doing something, either taking a photo or the user navigates into a web page. Hopefully I've made it a bit more clear what reactive scenarios there might be out there, but I'm going to show you a few more. Now, one of the offers that we have, because we got more than one serverless offer, is something called Azure Functions or serverless function on Azure. Now, before I go as far as to explain what those are, let's talk about the logo. If you've ever seen the logo of serverless, you're like, okay, is this some kind of DC Comics series? Is it Flash? No, it's actually code and events combined. So if you combine these two things, you get the Azure Functions logo. So now you can talk to your colleagues on Zoom or whatever you're using, or maybe Teams even, and you can tell them, aha, I actually know what the Azure Function logo is all about. Now, let's look at the Azure Function offer so we understand what is it that we're actually working with. Well, when it comes to Azure Functions, what we are working with is an Azure Functions app. And we usually refer to this one as the point of scale. So when this Azure Function scales for you, because you suddenly got thousands or millions of users, what happens is that it scales the Azure Function app instance for you. And in each of these Azure Function app instances, you have a number of endpoints. So imagine that you have 6 endpoints. Those would be in one Azure Function instance. And if it needs to scale for whatever reason, it's going to scale the function app instance rather than the function itself. If you look at the right here, you see how the function plays nice with everything in its surrounding. So if you see the function here in the middle, you see that I have a top bar here called trigger. Now, trigger is an important concept in Azure Function. A trigger simply means, why is this function running? It can trigger based on various things. I'm going to show you what it can trigger on, but how things play out is that a trigger is being triggered either by a time lapse, or maybe there's an insertion in a database, or maybe there's a new queue message, or you invoke a certain HTTP URL. What can happen for you at that point is that it can work with another central concept that is called bindings. Now, bindings comes in two flavors, input binding and output binding. Now, bindings, what those are is that they are connection codes towards a data source. So you no longer need to download an SDK for working with Excel. You simply specify, I have an Excel connection, or I want a connection towards a queue. And what you end up providing in this binding is the connection string or the API key, whatever is needed to connect. So you no longer need to say, instantiate an object of this and that type, configure it, run it. That's a thing of the past because you have bindings. So bindings will ensure that the Azure functions that you write are very small. So instead of it being 30 lines of code to connect, do the business logic, and then connect to another data source, you end up with something like 5 rows of code in that function, thanks to bindings. A third thing I want to point out is authorization levels. Now, authorization levels come in 3 different flavors. They either come as anonymous, function, or admin. Now, anonymous means that anyone out there on the internet could be calling your function. That's all nice and good for demo scenarios, but most likely you want to secure this up a bit by going to the next level of authorization, which is function. With functions, you need to provide an API key to be allowed to call this function, or it's going to send a response back that says you're not allowed to do this. With admin, you got a heightened level of security, and I believe it means that you need to be in the same group. So it needs to be a resource that is a known entity that calls my function. So you can definitely up the security level on your function as needed. I mentioned triggers as the reason why the function is running, and I mentioned bindings as a way to save a few keystrokes because you don't want to type too much code, right? So if we look here at triggers, we see that many different sources could be a trigger reason. So triggers are all about the reason why the code is running, and a trigger could be a blob storage that receives a new image file or CSV file, and the Cosmos DB can, for example, trigger on new rows or deleted rows, and an event hub can trigger on events. And HTTP, yeah, that would be a request that you make or someone else makes, and a queue, that would be a new message. A timer is where you specify seconds or minutes have passed with a regular interval, and a webhook is a webhook. Now, if you look at these bindings here, we have quite a few, but I thought I'd mention some. We see that the bindings can come in the flavor of a table storage. They could be an Excel, or they could be from OneDrive, they could be from email, a mobile app, a notification. So I urge you to go into the docs here and see how many types of bindings we have. If we have a binding that you need that's not supported, definitely reach out to me, because me and the serverless team are like this, right? But we have plenty of bindings, and hopefully all of those bindings are there to serve you for the scenarios you have. Now, if you remember the previous image with the function, you see that now we have replaced the word trigger with HTTP because that's a type of trigger. And we have replaced the input binding with a database. So for example, we have a new row being added to a database, and we have replaced the output binding with that of an Excel. So what this means practically is when your function is being invoked, it means that the input binding will connect to your database, but you can also supply it with a query statement. So your function runs, and immediately at the start, it has access to maybe 30 records from a database. And this is really the strength of the Azure function, is its ability to prefetch that data for you. So once you execute the function, you have that data, you can select that data that you want, and you can end up pushing that data into an Excel sheet, for example. And you can do all of this with 5 lines of code, thanks to the bindings. Now, how do I go about to actually author the serverless function? Well, there are a few scenarios. You could use the portal. I recommend when you first try out serverless that you do so in a portal. That gives you a nice way. I wouldn't recommend using the portal once you go enterprise and really go all in serverless. At that point, you want to go with a middle alternative, which is to use an IDE. You could be using Visual Studio Code or Visual Studio or WebStorm, for example. We have extensions for this. And even if your IDE is not mentioned here, you can use something called the Azure Function Core Tools. What that tool set allows you to do is to scaffold, to debug, and to deploy an Azure function. So this is the option that's great for CI/CD scenarios, but also if your IDE is not fully supported for whatever reason. Now, how do I get there? How do I prepare my machine so I can start developing Azure function? Because at this point, I'm thinking this sounds good, right? Well, there are different instructions depending on whether you're on a Mac, Windows OS, or an Ubuntu, for example. These instructions change a little bit over time. Let's see if I can move this Teams thing for you. There we go. So I definitely urge you to go into the bottom right link here to ensure that you have the latest and greatest instructions, because those might change slightly over time. But roughly, if you look at the Mac and install Azure functions there, you're looking at installing 2 sets of packages. And on Windows, it's an npm call, and on Ubuntu, it's about retrieving the right type of package. Really, my favorite out of all of these tools is the Visual Studio Code extension. It is great. I mean, what it allows you to do is it allows you to scaffold the function, but also debug it locally. And we all know as developers how much the developer experience matters to us. If I can scaffold my project locally, if I can debug it locally, it just builds that sense of security. And speaking of which, if you're actually deploying for, if you're developing for the .NET runtime, you can actually debug live, and that's fantastic. So you can actually, if you are using .NET, there's a setting in the Azure portal where you can say, I want to enable remote debugging. And just imagine that you would remotely debug something that's deployed. And if you have an error with that function, you can definitely see what goes wrong. But that's only for .NET folks so far. I know they're working for support for other runtimes, but yeah, if you're a .NETer, you have a reason to celebrate a little bit. Now, let's show in a demo how we could be scaffolding our first Azure function, because as I said, the extension for this is really great, and it gives you the ability to do all the things you want to do without spending a single credit. And we like that, right? We don't want to spend any cloud credits if we don't have to. And this also gives you the ability to evaluate whether Azure Functions is something for you. Now, let's kick off this demo. It's a video recording, by the way. First off, I'm going to show you the Azure Function extension, so you see what that one looks like. You search for Azure Function, and as you can see, it's quite popular. It has quite the feature set that I mentioned partly already. You can deploy, you can scaffold, you can debug, all these things. So if you are interested, definitely go into Visual Studio Code. I believe there's a similar extension for Visual Studio where you can go and see. Now, I don't know if you were with me there. Oops, sorry about that. I'm going to rerun this one. There we go, from the beginning. I was a bit quick. Yeah, you just gonna have to hear those few first seconds again. What we are doing here is that we have the Azure function, and what we're going to do is to scaffold a project, and the project is an Azure Functions app. What we do is to leverage the command palette. So most functions out there creates commands in the command palette, and we can definitely bring those out. On a Mac, I believe it's Shift Command P, but it might be different. So here you choose the runtime. And as you can see, it's JavaScript, TypeScript, C#, Python, Java, PowerShell. So there are quite a few options depending what you have. Here you're supposed to select a trigger. We have quite a few triggers, quite a few reasons why this code could be running. It could be run due to HTTP. It could be run due to a blob storage, a new file being created. It could be a new queue message. So yeah, as you can see, there are quite a few triggers where we can choose from. At this point, I'm going to choose a simple HTTP trigger, and I'm going to provide it with a decent name. You can change this name after the fact if you don't like whatever you named it initially. And here we select the authentication level. Now, I select anonymous for this demo, and you can definitely go in and change that as well. This is the files that you get scaffolded for you initially, host JSON, local settings, and you see this compute subfolder. This looks a tiny bit different for .NET. But as this one is scaffolded for Node.js and JavaScript, you can see that how we have the context input param and the request input param. The context enables us to log, so this will be showing in the portal once it's deployed, which could be great for debugging. And you can see how we are able to parse out query params, a posted body, and so on. And we need to construct a response object. So once we construct this response object and it hits here code-wise, that means our function is returning. Now, if we look at the configuration file, the function.json, you see how different methods, HTTP methods, are being supported. We can definitely edit this list to limit what it reacts to. At this point, it would support get, post, and put, but we can just remove those as much as we want to tighten up what it should respond to. The HTTP trigger is the type, and we also have another type which is HTTP, and have a look at the direction here, which is out. And this means that we have an input and we have an output. So we need to think in terms of flow. Data coming in, which would be trigger or other type of bounded input data, an output would be what we define, what should we write to. In this case, we write an HTTP message, but we could be writing, for example, to a queue or Excel instead. Because this is HTTP, what I wanted to show you here is how this response is being constructed. What we are doing is to set the body property, and we can also set a status to something else than 200 if something goes wrong. Here you see how I started debugging for all of this, and I'm going to show you how that works. So by hitting this link, I can actually click this link right from Visual Studio Code, and you see how the debugger is hitting straight away. And I can just hover over this, and this is really nice if you're a developer, right? You're able to see exactly what the request object consists of, and you can see that we didn't pass any query parameters, so this is fine, that is undefined. And we can set as many breakpoints as we want, and we can move from breakpoint to breakpoint. And what we're doing here is to simply echo back a hello message with whatever was posted. And at this point, we have dug something out of either the query or the body. Yeah, so that's how that would work. Let's see. Okay, so what you saw in that demo was the fundamentals of starting with an Azure function. And what we did was to scaffold the function app. We ensured that there was at least one endpoint. We can definitely add more endpoints. What we also did was to ensure that it was of type HTTP trigger, which means it could be reached from the web, or we could use curl, for example, to reach that endpoint. And we ended up reading data from a param, and we can make that as part of the response if we want, or we can use that to filter data. Hopefully that looked like it was interesting, and I just want to emphasize we didn't spend a single credit doing any of that. Now let's talk about handling events at scale, because I said all of this with serverless is event driven. And by saying so, what I am saying is that we have event solutions. We have something called the event grid, which is really, really powerful. So when you're dealing with events in the millions, it makes sense to have an enterprise solution for that. You can definitely build that locally, but do you really want to? Do you really want to have a number of machines locally that's able to handle all of those events, think about backing up events and so on? If you have that business case, we definitely have a service for you. So if you have a look here, you can see that there are different types of events, and events can come from all over the place. Come from GitHub, cognitive services, from other Azure resources, Cosmos, and so on. All about these events, and there can be many of them. So let's have a look at some more scenarios. You can, for example, have a serverless function that's being triggered to run an analysis because a file is being added. Or you can have ops automation. Imagine that someone is scaffolding up a new resource group, and you want to augment that resource group with some business specific data that only the ops team knows about. This is a great case for them to be using this. And you can also use it for application integration, because what you saw in the first demo here was me calling this endpoint. And by calling an endpoint, you can actually be on-prem calling an endpoint in the cloud, and it would trigger a set of events. So you can see how we can leverage on-prem to talk to the cloud this way. Now, when it comes to managing a lot of events, what we need to realize is that there are a few concepts we need to understand what they mean. First off, there's a thing called publishers, and a lot of things in Azure can publish events. I think most resources that you can scaffold are capable of publishing events. So blob storage, a resource group, a subscription, an event hub, even custom events that you define, that you raise for whatever reason. All of those are publishers, and they're capable of raising events. And then you have event handlers, which is the other side of the coin. Event handlers could be an Azure function, a piece of code that you have written, or it could be this graphical thing that you have created that we will look at the end of this presentation called logic apps. Or it could be as part of an Azure automation and webhooks. So we have publishers that raise the event, and we have event handlers that respond to the events and carry out some business logic because something happened. Now, back to this solution, because you don't want to build all of this event handling on premise. You can do it if you're really capable, but you want to leverage the fact that the cloud exists, right? So what we offer is a solution called Event Grid, that has the capability to have a very low latency, and it's able to handle 10 million events per second and per region. It may not be fast enough for the stock market, but it's definitely fast enough for most business application. There's also a 24-hour retry with an exponential backoff. So that's kind of good to know if you go down the path of saying, hey, I want to use this eventing in the cloud service. So 99% availability, a lot of subscriptions, and transparent regional failover. So if it fails in West Europe, it can fail over to whatever region is closest, and you don't have to know anything about it because that's up to us to make sure that we always serve you. Now, let's repeat these concepts again. We have the concept of an event, which means what happened. We also have a concept that's called an event publisher, which says where it took place, a resource group, a blob storage. Excuse me. We also have a topic that says where publisher send events. And we lastly have event subscriptions. And a subscription is a connection between a specific topic and a handler. So I'm going to show you how to create these subscriptions shortly. And event handlers finally is a piece of code. So either you wrote that code in Azure Functions, or that code is written for you because it's a graphical programming thing in a logic app, for example. Or yeah, the important thing is to realize about the event handlers is that it is code that runs because something happened. Let's have a look at an event grid, because that's what this solution is called. And let me show you. I'm going to do all of this demo inside of the portal, but you can definitely do all of this inside of Visual Studio Code. But I just want to show you how you set up the various parts. Now, if you start here with a function app, the function app has this trigger, which is of type event grid. Yeah, let's head back here and look at the overview, and let's have a look at, let's go into our function, because the first thing we want to see with our function is what it looks like. Okay, so if we look at the code and test part here, if you're using the latest version of the portal, I believe there's 2 different versions of the portal for Azure Function. This is the newest one. So here we're looking at a very similar construct to that of the HTTP trigger, if you remember. It has 2 input types, context and event, grid event, and all we're doing is to log out this event. For now, this is maybe not very useful from a business standpoint, but it's good. What we're going to look at next is subscription. Now, a subscription is resting on is something that we can create. It's based on a topic, so we need to drill down to a specific storage account. Here we have one created called blob create. If we go into this one, we can see a bunch of stats, but what we really want to know is what type of topic are you subscribing to and who's running code because of it. And we can see that it rests on a storage account here called for blobs. We can see that we have chosen to subscribe to blob created. And yeah, so we have a blob created subscription already created, but I will show you next is how we can be creating our own from scratch, because that was pre-made, pre-baked. So the first thing we do is to give it a name. So we give it a name, and next up we give it a schema, and we need to say, hey, it's on a storage account. We need to select our subscription. Once we do that, we need to select a resource group. Everything in Azure needs to be in a logical bucket. And then we need to select our storage account. But instead of this blob created topic, we're actually going to take away created and say, hey, we want to listen to deletion events. We want to know when a file in the blob storage is being deleted. And next we're saying what type of event handler we have. It's an Azure function. Once we select what type of handler, we need to go more into detail. So we're going to go with Azure function for now. So we need to select what endpoint. So first off, we point out where's our function app. It's on this and that resource group. So we try to find our resource group. Once we do that, we find the function app in question, and then we find the function that's interesting, the endpoint. This is the one that I showed you initially. So, okay, we have set up this subscription. We are ready to push create. And that's great. This is creating our subscription for us. And now we have a connection between a file being deleted on a storage account and a piece of code that's going to run. So what we want to do at this point is to make sure that these subscriptions exist where we think they do. So we filter a little bit in the search and we can see that, okay, we have a new one here. Blob create that we had since before and blob deleted. Great. So we have done everything humanly possible to set things up. What we want to do though is go into the function and we want to make sure that we show the logs, because we're going to have to inspect these logs because we will actually trigger this event. So we're here, we bring up the logs, and as you can see, nothing has been calling it at this point. It's just showing us some default text. Here we have Azure Storage Explorer open, and we have 2 files in there, and we're going to delete one of the files. So we're going to select this file, we're going to hit delete, just have to right click, and we hit delete, yeah, there it is. And we click it, and we're going to be prompted, are you sure? Yes, I'm sure. Go on to delete this file. For real. And once we delete it, we need to refresh because we want to see that, you know, the deletion actually took place. We select yes, and we see we have 1 file left. That's great. Aha, look at these logs, right? We see that it was triggered because of this, okay? Because we subscribe to deletions and it's telling us all about what happened. It was a specific file that was deleted, and yeah, so you can see how simple it is to actually listen to events in the cloud and connect a specific topic to a specific event handler. And that concludes the demo for the event grid. But realize that Azure Functions is just one of many event handlers. We could have directed this towards a number of different event handlers. So at the end of the day, what we can build up is a very complicated grid. So imagine that you can almost bring in your full business in here and start integrating either from on-prem or from various types of resources in the cloud, and you can listen to things and you can have code run and you can have code that actually raises events in turn. So it's a lot of events that you can manage. Let's talk about workflows next, because Azure Functions has, well, limitations, I think is the best word to use. So imagine that it's not an HTTP trigger. At best, you have 10 minutes to finish that function invocation. And sometimes that's not enough, because you might have a workload that takes 11 minutes. And what do I do at this point? Am I not able to leverage serverless and the fact that it's so cheap? You might be, but you might need to think about it differently. You might need to slice up your workload in different pieces. And if you're an HTTP, you might be worse off. It might actually time out after 2.5 minutes even. So it's good to be aware of these limitations. But what if I have a longer running workflow for days and weeks? Can I still leverage serverless? Yes, you can. And that solution we have is called durable functions. So if you haven't heard of durable functions, this is going to be a treat for you, because this one is event driven and we actually store the state of where this function is at. So as long as you're able to slice your workload and everything it does into neat little pieces, you can have serverless that lasts for months or years. Let's have a look. If you think about this as a process instead, and this process have a lot of logical gates. So imagine that you are in a car factory, and because I'm a Swede, I'm probably gonna talk about the Volvo factory in Torslanda in Gothenburg, right? Or maybe Saab in Trollhättan. Sorry about the Swedish references, y'all. But if you're looking at this, imagine that you have a car and you have a few events that needs to happen to this car before we can deem it to be ready for production and for you to put the keys in the car. What needs to happen? Well, you might need wheels. Everyone loves wheels, right? Unless it's a hovercraft. And you definitely need doors unless you really like your AC. And you most likely want some kind of steering. So imagine that those are events instead. You have an operator that says, I added a set of wheels, and now I'm going to push a button and I'm going to raise an event that says wheels are done. And then you have the next operator that says, OK, I'm going to weld the doors to the car. Once I'm done, I'm going to hit that button, and that's another HTTP request. And lastly, someone says, hey, I actually added the steering wheel, and at this point your car is not nice looking, but it works, right? And your last step in this might be to add a color of paint, right? At this point you have a Volvo that you're not ashamed to show your neighbor, right? So if we look at this, these event gates here, we can see how the first event could be that your you have like this skeleton of a car that maybe is only the engine that's in Torslanda at Volvo. And then you have these 3 events that all of them need to have happened before we can move on and cover that car with paint. So what durable functions allows you to do is to set up this kind of business logic where you can just say, either we have events that happens one after the other, or we have events that needs to happen in parallel. But the important part in this case in F2 here is that we act as a blocker. We actually don't do F3 unless all of these events in F2 has happened. Now, there are a few concepts to know about when it comes to durable functions, so it makes it easier to digest how it would work. An important thing to know about durable functions is that you should look at them as instances of a workflow. So every time you start up this workflow, you get a unique ID. So every time you want to refer to a specific invocation of that workflow, you need to have that unique ID, and you need to tell it what kind of event that you want to raise to promote moving from one state of the function to the next. So at this first point, you can, for example, choose to trigger it based on an HTTP call. At that point, when you trigger it to start, what should happen is that you start up something called the orchestrator. And the orchestrator is the brain. So if you look at it like this, you see that the orchestrator is able to define a workflow. And because it is the brain, here is where you would put a business logic that would say, this is what I want to happen. These are the events that are dependent upon each other, if there are dependencies, and you should be checking those events and make sure, have this finished? In that case, I can continue. Now, there is a third concept that's important to know about, and it's called activity. An activity is the workhorse. That's the one carrying out the calls. For example, talking to a database and inserting a row, or updating a row, or maybe sending a text, whatever makes sense for you as a business. But know that activities are the workhorses. Now, lastly, we have something called events. Now, events is you signaling, or your system signaling, that you need to move from one state to the next. So you're saying something important happened. Here's a piece of payload, and I want you to take that payload and send it to whoever cares, whoever listens. Now, I thought I'd show you what this could look like with a concept that you might know about if you've seen Lord of the Rings. If you haven't, it's about a movie where they are on a mission to destroy this ring that's really evil. If you know about it, you know that there are some characters in there, like an old wizard called Gandalf. And there's also Bilbo, who's one of the hobbits, really short. And there's also Dvalen, which is a dwarf. And what we know about this hobbit dinner is that a lot of people crashes this poor hobbit's house, and they're eating everything and they're drinking everything, and he feels like he's dirt poor after this, right? So how does this relate to durable functions? Well, imagine that Gandalf arriving, Bilbo arriving, and Dvalen arriving are 3 important business events. So when all of these 3 have happened, then they are at the state where they can actually talk shop, where they can start to plan how we're gonna go from the Shire into Mount Doom and actually drop that ring so it's destroyed. So that's how you can, refer to these different kinds of events. Now, I'm going to show you a demo how that would play out, because you can definitely scaffold this durable function app using the Azure extension. Let's start this demo. Now we're inside the Visual Studio Code, and we have created this durable function thing. If you're in .NET and JavaScript, this looks slightly different, but for the orchestrator, it's placed all the functions in one place. You can definitely place those in different places if that makes more sense for you. Now, looking at the first one here, we see the entry point, HTTP start. This is the endpoint that we need to call to kick off this orchestration. What happens when we kick off the orchestration is that a orchestration instance is being created. Now, we're still looking around a little bit just to see what functions we have. Here's the orchestrator. We see how it has different events that we want to listen to. And we also see that there's a condition where it's like an if clause and say, have these occurred? If yes, on line 30, that's where I want you to continue to run. Okay, so we have all the functions, but I'm not going to take you through this. So let's start by debugging this. So once we are debugging this, we are going to start with a bunch of endpoints. Now these endpoints in a few seconds is going to show. yeah, here you can see we have HTTP start, we have find the ring as an activity function. Yeah, we have a bunch of endpoints, but what we want to do is to make sure that HTTP start is being called first, because that's the entry point, right? So we call HTTP start, we can click that, and we see how this breakpoint is being hit. Now, at this point, I'm interested in creating the workflow. And by us calling the orchestrator, that means that we get a unique instance ID. And once we have that unique instance ID, we have a unique reference that we need to refer to in all our future calls to refer to this specific invocation. If we invoke it with the wrong ID, we're going to affect a different workflow that we most likely are not interested in. Now, if we hover here, you see that we get this instance ID. We could be persisting that in a database, for example, if we want to show all the running instance IDs. But once we have this, we have our function, and now it's up and running. And the next thing it does is actually to trigger the orchestrator. Now, what the orchestrator should be doing at this point is to start evaluating whether these custom events have occurred or not. And I'm just taking you through the code here so you can see. We see that the breakpoint is here, and we see that it's trying to investigate. Has Bilbo happened? Has Gandalf happened? Or has Gimli happened? At this point, none of these have happened, so it's just going to stop here. It's not going to go to line 30 because it's going to say, you know, they are still false, right? What I need to do at this point is to go into a web browser and start to do something about this. This is what faces you once you start your workflow the first time, and this is the unique ID. So we can use this unique ID and we can pop up a new tab in our browser. So now we have our unique instance ID, but we want to call this arrive function because this is the one that's going to raise events. So we need to give it the instance ID, but we need to see what is this called. Okay, we're going to read something called instance ID. This is a query param, so we specify that. And we're going to set that equal to the value that we just copied, but we also need an event data. This is the name of the custom event that we're going to raise. Yeah, and we're going to copy that again in case we lost that copy. And we paste it. And now we're going to say, what's the name of the event that we're interested in raising? Let's have a look. I can either choose Bilbo, Gandalf, or Gimli. Anyone will do at this point because all three of them need to have occurred. And at this point, I'm raising events. Okay, so the first event has happened. We see that the arrive endpoint is being invoked, and this is going to raise a custom event. And once we raise this event, our orchestrator is going to be called to verify where we're at. So now you can see we went from the arrive endpoint to the orchestrator, and the orchestrator is going to evaluate. Now, only 1 out of 3 custom events have occurred now, and this gate is not going to let us pass until the other 2 has happened. So we need to go back into our browser yet again and say, hey, we need to raise these 2 other events before this gate is passable. So we go in here and change this from Bilbo to Gandalf. That's the second event of 3. And our code, our orchestrator is going to be called right after we pass through the arrive function and we raise this custom event again. So once we go through here, we come to the orchestrator, and at this point, 2 out of 3 events have happened. We still have 1 left. And to be able to actually finish this off, we need to raise the 3rd event as well. So almost there. Okay, so what we need to do at this point is to raise the 3rd event with Gimli. But before we do that, let's have a quick look at the state that we're in. So we're going to go back to this tab, and we're going to go to this status URI that tells us we are still running, which is true. 2 out of 3 events have occurred. This instance is still running, but we want to change that from running to completed. So let's head back to that tab again, and let's raise the 3rd event out of 3. So we go back here and we hit enter. At this point, the arrive endpoint is being hit for the last time because now we have the 3rd event that we are waiting for, and we're just going to let that debug breakpoint go to the orchestrator. Once we come to the orchestrator, we can now see that all 3 events have happened, and we expect line 28 here to actually say, good, let's move on to line 30. Which it does, right? It used to quit on us on line 28. So now line 30 has actually been passed, and we can see that lastly, we are calling this last activity function, and we end up in a finished state. So first we call that a sync function, and we're going to let the breakpoint go through. And the last thing is going to happen is that it's going to first do the return, and then it's going to do one more loop through the function just to make sure that everything is good and fine. So one more loop, just checking all the events. Once it's done all that, then it's going to return the end state, which is flow done. And hopefully at this point you understand how durable functions work, how they work with custom events, how they are event driven. We don't have a ton of time left, but hopefully I can at least mention what low code and no code is before we do a little Q&A, and I can definitely stay on the stream if needed. So for low code and no code, what we're saying is that we are dealing with graphical components that we drag and drop rather than to actually write code. So if we look at logic apps, what we are looking at is a workflow engine in the cloud. So this is BizTalk being reimagined, essentially. This is BizTalk in the cloud, for lack of a better word, if you've ever used BizTalk. So what we have is a concept called connectors. Connectors are pieces of code that is represented as graphical boxes that you can drag and drop. So even if you don't have any code experience, you know that an external event should lead to, for example, an email being sent. We have hundreds of connectors, and if you're still not happy with the connectors we provide you, you can easily write your own custom connectors. Now, looking here at the top right, you see how this flow goes from top to bottom, and we see that we can do certain things in the flow. We can listen to tweets, we can set variables, we can query documents, we can talk to cognitive services, and we can even have branching logic where we decide if the value of this response or this response property has this value, then we kick off a bunch of events or a bunch of code. And if it's else, then we might end up in some kind of end state where we send an email to the admin. So this is a very different ways of carrying out serverless, but imagine that you have one of these Azure function code that actually triggers a custom event that triggers logic apps. So you can see how you can have your entire company inside of this, because this is meant to be cloud native. This is meant to be accessible and low code. And we can connect a lot of things: service buses, cognitive services, machine learning, Office 365. There are all these opportunities for you to integrate various things in the cloud. And just to sum things up really quickly, I showed you a lot of different serverless offerings. Serverless is code that runs in the cloud for a reason. I've shown you about triggers, something happens. They are event-based, and because there are so many different offerings and so many resources in the cloud that could generate events, this is your opportunity to architect in a new way. It is cheap, but see it as an opportunity as well to integrate things that you have on-prem as well as things in the cloud, because if you define an HTTP trigger in the cloud, your on-prem app can definitely talk to that one if you provide it with a proper API key. And there are different types of serverless offerings: Azure Functions, workflows, logic apps, and more. And I just wanted to show you that there are definitely things on aka.ms/learn. If you haven't discovered Learn yet, there are over 2,000 modules in there, and I believe there are 20 plus modules dedicated to serverless and our different offerings, and more modules are being added as we speak. So if you want to learn everything about serverless, definitely do so on Learn, either by using our sandboxes that don't spend your credits, or try it out with Azure Functions to have that run locally in Visual Studio Code. Now I'm going to leave this over to Emma. I think you have an outro slides, and definitely open this for Q&A. Thank you all.
Great stuff. Thanks so much, Chris. Excellent session. And we have had a few questions come through. So I know we're running a little bit over, but we'll hang on for questions anyway, which is absolutely fine. So Charlie asked earlier on, how does ping, traceroute and DNS resolution work with serverless and Azure?
Oh, I don't know, to be honest. Can we save this question? I need to go back to the serverless team exactly and ask them.
Yeah, absolutely. We can come back to that one. Okay. We had a question from Irvin. How do you support inbox email trigger in Azure Function?
Azure Function, inbox trigger. I don't think we support it currently, but we have it as a connector on logic apps, I remember. So if you do that as a logic app, I think that will work out fine. So what you can do with the logic app is to listen to that type of connector trigger, and then you can trigger Azure Functions code as a result. If it's not supported, that's definitely something we want to hear about, if that's an important part of your everyday business.
Great, brilliant. We had another question from Charlie saying BI is fine and event handling, but that is the receiver side. How about the security for the users of a system?
Security for users. Yeah, so we have authentication model, right? We had the anonymous, which is no security at all. We had the function level, which is an API key. And we also had the admin level. So I recommend having a look at the function level authentication or authorization, as well as the admin one. So we can definitely secure this up as much as needed. And I also believe that we can integrate with the Azure AD if needed.
Great, brilliant. And the final question I can see for now has come from Andreas. What's the state of the logic app versus code plugin?
Right, so I believe that's gone really, really far. I think you can look for it now. I can't remember if it's an internal session where I was shown it working really fine, or if it's actually gone GA, but from what I've seen, you can definitely be authoring logic apps in Visual Studio Code. I think it might be in a beta or like a preview state, possibly still. If it's still in that state, if you want me to ask the serverless team where they're at, I'm happy to do so.
Okay, great stuff. And that's all the questions I see coming through. Is there a way, Chris, for maybe attendees to reach out to you after this session if there are follow-up questions, maybe your LinkedIn or Twitter, if we're able to share that out? For sure.
Let me just, I think I wrote that in the slide deck, but I'm going to post it in the chat as well. So that's my Twitter address. My IMs are open, so definitely do so.
Brilliant. Great stuff.
Also, if there are any asks, if you're on AKA MS Learn and you feel like, hey, there should be a module on X, I want to hear about that too, because we're creating content all the time. So if we're missing, if we have a gap, we want to know.
Mm-hmm. Yeah, absolutely. That's a good point. Great. Okay, I don't see any other questions. I'll stop recording this now. Tune in next week, same time, same place for our next session. So let me just get next week we have Dimitri joining us, and Dimitri is delivering a talk on face application programming interface and creative cognitive portrait. So it's going to be a really interesting talk. I hope to see everyone there. And thank you for attending today, and thank you so much, Chris. It's been a pleasure to have you, and hope we have you back again soon.
All right, awesome. Right, thank you, everyone.
Bye, everyone.